You can never have enough VCAs is the most common phrase you'll hear in the modular synthesizer community. While I agree with this sentiment, I think we should really say you can never have enough utility modules. Mixing, inverting, attenuating, and offsetting signals are just as important to help our modules work together and add nuance to our patches. So today I want to highlight one of my favorite utility modules, the Toppobrillo cluster. The Toppobrillo cluster is an 8 HP voltage processing module inspired by the classic Buchla 257. Unlike the 257, cluster is designed to work with both audio and CV signals equally well. Cluster contains 3 channels that may be used independently or together. From top to bottom, we have the XY channel, a voltage-controlled polarizer, also known as a 4-quadrant multiplier, the AB channel, a voltage-controlled crossfader, and the Z channel, an attenuverter or offset generator. There are separate outputs for each of the channels, as well as a summed output and an inverted sum output. Patching from a channel output will remove it from the summed outputs, allowing the use of any channel on its own and preventing unwanted feedback loops. Each channel features LEDs for visual reference, green for positive voltages, red for negative, and center detent potentiometers to make zeroing out signals more convenient. While at first glance this module just seems like a few simple utilities, there is more a cluster than meets the eye. One can creatively patch the channels to create functions such as amplification, ring modulation, ducking and sidechaining, full wave rectification, voltage mirroring, and Boolean logic. Let's break down each section and look at some patches. The XY channel is a 4-quadrant multiplier or voltage-controlled polarizer. There are 2 inputs, X and Y, which simply get multiplied together at the output. There's also an attenuverter that controls the Y amount, giving us more control over the final level of the channel output. Both inputs respond to both unipolar and bipolar signals, unlike a traditional VCA where the CV input only responds to unipolar signals. The Y input, when unpatched, is normalized to a voltage offset, meaning the XY channel acts as a basic attenuverter if you only plug a signal into the X input. Turning the Y amount knob lets us scale and invert the X input. Let's look at some XY channel patches. To patch the XY channel as a basic VCA, I have an audio source going into the X input and a dynamic unipolar envelope going to the Y input. The XY output is running into a delay module and finally to an output module. With the Y amount knob at noon, the output is silent, but rotating the knob clockwise from noon increases the envelope's gain. The LED between the inputs and the knob gives us a visual indication of the output signal. Here, an audio rate oscillator is plugged into the X input. With nothing plugged into the Y input, the knob acts as an attenuverter. Plugging a bipolar signal into the Y input will now allow this channel to behave as a ring modulator or 4-quadrant multiplier. Positive voltages into Y will increase the gain of the X input, while negative voltages into Y will similarly invert the X input. The Y amount knob acts as an attenuverter for the Y input and can be useful for fine-tuning the output gain and polarity. Boolean AND functions are possible by plugging a different gate sequence into each input. The output will then only go high when both inputs are high, which is great for creating more sparse gate patterns. The AB channel contains a linear voltage-controlled crossfader with a toggle switch to enable a voltage offset. There are 2 inputs, A and B. there is a voltage controlled input with manual offset knob. At the center detent, there is a 50-50 mix of the A and B inputs. Each signal will be at half amplitude. This channel enables many of the more complex functions of the cluster. With nothing plugged into the A input, flip the reference switch up to switch in a voltage reference. You can select the voltage offset of the ref switch via a jumper on the back of the module, either 4 volts or 8 volts. If you don't need voltage control of the crossfading, no big deal. Just use the manual control to switch smoothly from A to B. Now let's look at some patches using just the A-B channel. In this patch, I have 2 separate gate sequences going into the A and B inputs. The output is being slewed by the sport modulator and then is being used as an envelope on the XY channel setup, like in the previous VCA patch. Crossfading between the A and B inputs creates a shifting dynamic gate sequence, but we can get back to the original sequences by moving the knob to the extreme positions. By multing the B gate into the crossfading input, we can emphasize the B sequence and play around with the strength of the A sequence. I love using this technique as a way to add accents and ghost notes. Here we are using the cluster to control the panning on a channel of the mini-mix which only responds to positive voltages. The ref switch creates an offset voltage and centers the panning. Plugging a bipolar LFO into the crossfade input effectively fades between 0 volts and 8 volts, creating a swirling panning effect. Note that this patch does change the polarity of the LFO, but we could always use the X, Y, or Z channel to fix that. To use the AB channel as a Boolean OR function when inputting gate sequences, just mult the B input to the crossfade input with the knob at minimum. Last but not necessarily least is the Z channel, which provides a manual offset with no input or acts as an attenuverter for external signals. With no signal patch, the Z knob provides an offset of 4 volts, or you can change it to 8 volts with a jumper on the back of the module. Patching a signal into Z allows you to scale and invert signals. Let's look at a couple of Z channel patches. Here I'm using the offset from the Z channel to control the Just Friends run input. The offset amount will change the digital Vactrol emulation's decay. In this patch, I'm attenuating an LFO going into Mimeophone's micro rate input to create a warbling chorus effect. Without generous attenuation, this effect quickly gets into seasick territory. Finally, let's see some patches involving multiple channels of cluster. For this patch, each channel cluster is performing a different function. The Z channel is attenuating an LFO into Mimeophone's micro rate input just like before. The XY channel is being used for audio rate ring modulation. The AB channel is used for ducking or sidechaining by patching an audio source into the A input and a unipolar envelope from the kick drum into the crossfade input. Multing a single source to every channel and taking an output from the sum output allows for cluster to act as an amplifier. Listen to how the increased gain overdrives the multi-filter input. Inverting the Z channel makes this drum loop go back to unity gain. It's possible to turn a bipolar LFO into an attenuated unipolar LFO by using all three channels of cluster. For this patch, I'm sending an LFO from Sport Modulator into the X input and turning the Z channel all the way up to generate an offset. The sum output is patched to the B input, and AB output is used as the final output. The crossfade knob controls the range of the LFO from 8 volts to 0 volts. By patching different sources into the X, B, and Z inputs and using the sum output, it's possible to use the cluster as a 3-channel mixer. There are gain controls on each channel and inversion on the X, Y, and Z channels. Remember, this patch works for both CV and audio signals. This clever patch from Toppobrillo's user guide allows cluster to morph from no modulation to amplitude modulation to ring modulation without a drop in output amplitude. An audio source is patched to the X input. A bipolar modulation source is patched to the B input. The ref switch is turned on. Patch the AB output to the Y input and monitor either the X, Y, or sum output. With the AB knob at minimum, no modulation is applied. Around noon, we get amplitude modulation. At maximum, we get ring modulation. Don't forget we can use CV to control this crossfading. Thanks for joining me on this demonstration. It's easy to forget how important utilities like cluster are in a modular system when there are a ton of sophisticated modules out there. But the utilities are what make systems work more effectively. Eurorack is a sea of different designs and approaches towards voltage ranges, size constraints, and features. Having a module that bridges these different designs is vital. Hopefully you get something from this demo, whether you are thinking of picking up a cluster or you already have one in your rack. If you want even more patch ideas, I highly recommend checking out the user guide on toppobrillo.com. Thanks again. See you next time.